Okay, here we go. First, a quick review of what acids and bases are, and then we'll talk about pH. So, acids. We're going with the simplest, the first definition that people learn about acids, and that is that acids are chemicals that, in solution or when dissolved, they release protons. Okay, so acids release protons in solution. What's a proton? Well, that's basically, it's just a hydrogen ion. So you'll often see it written like this, just H+. Because if you have a hydrogen atom and it's lost its electron, it is just a proton. So that's what an acid is. An example of an acid would be hydrochloric acid. Looks like this, and if you take it and throw it into water, it splits apart into a proton and a chloride ion. And this is what makes an acid an acid. Okay, you already knew that. All right, and the easiest definition of a base, the simplest one, is that in solution, anything that releases or creates, releases OH negative ions. Those are called hydroxide ions. And what is that? Well, an example of that would be sodium hydroxide. NaOH. This is the one that we start off with talking about usually. What does it look like? Well, there's a sodium atom, an oxygen atom, and a hydrogen atom. When they get thrown into water, what happens is the sodium loses its electron, so you get a positive sodium ion, and then the oxygen and the hydrogen stay together as a negative ion. That thing right there is called the hydroxide. It's called a hydroxide ion. So now let's talk about pH. What does pH stand for? It stands for the power of the hydrogen ion concentration. Or you might see someone say power of hydronium ion. We don't care. Hydronium is a weird word that we don't need to worry about. But for us, it's good enough to say pH stands for power of the hydrogen ion. Okay? So, what is pH? It's a scale. It's a spectrum. And it goes from small number, 0, and beyond actually, and it goes out past 14, but this is what we typically talk about. So if something is right in the middle, 7, it is neutral. What does that mean? That means that it's got an equal number of the H pluses and the OH minuses. So if they balance each other perfectly, then you have a neutral or a pH 7 solution. So what happens if we have more of one of these or the other? Well, let's talk about H plus first. If you have a whole bunch more H pluses, then your pH goes this way. Your pH goes down. And we call that acidic. So acidic means more H pluses. And that's a low pH. And likewise then, the OH negative, we call that basic. And that means more of the OH negatives. And that means a higher pH. So that's numbers out this way. Other people have made way better pictures than I can about this. So let me bring in one of those. Let's see here. This one is a decent one. And this is a pH scale. And right here we see in the middle, 7 is neutral. That's pure water. We've got our H pluses equaling our OH minuses. And then as we get more and more acidic, we get things that you guys have heard of before. Like you've heard that vinegar is acidic and pop is acidic, lemon juice. You guys have heard those things before. And then usually for whatever reason, students are less familiar with bases. And bases have, remember, they have more of the hydroxide, more of the OH minus ions. So we have things like your blood. Your blood is just slightly basic. Milk of magnesia, like that Pepto-Bismol type stuff. Ammonia is pretty basic, out here at 11. Soap is basic. Drain cleaner, sodium hydroxide, is basic. So how does the scale work? It works like this. I told you already that at 7, the H plus equals the OH minus, and you know that as you go this way you get more H pluses and this way you get more OH minuses. But how many? Well, it's kind of like the metric system, because as you go from one step to the next step, it's a difference of 10 times. So if you go from pH 7 to pH 6, you've got 10 times as many of the H pluses as you did have. And so then if you go from 6 to 5, 5 has 10 times as many H pluses as the 6 did. So then if you skip 2 steps, that's, 100 times. So that means something with a pH of 5 has 100 times as many H pluses as something with a pH of 7. So when do things start to get interesting or dangerous? Well, I mean, maybe you've heard you shouldn't keep orange juice in your mouth for a long time. You should swallow it. Lemon juice, the acid in lemon juice will eat your teeth away. So down here is actually fairly strong acid, but when it really makes a difference, when the 10 times 10 times 10, when it really starts to build up is when you get down here. When you get into this neighborhood, we're talking about battery acid and those sorts of things. And you've got some pretty strong acids. And the same thing goes out here for the bases. When you go from 7 to 8, you've got 10 times as many of the OH minuses as you did at 7. So, if you 10 times 10 times 10, when you get out here, this is 1,000 times as many. So, out at this end of the scale, bases are also pretty darn dangerous. So, without doing a whole lot of math, here is a quick little video, or here was a video about acids, bases, and pH.